tackling a do now problem or problems. Some easier than others, I guess. So state the do now. State the y-intercept of the exponential equation and classify it as either growth or decay and explain your answer. All right, so the explanation part of it doesn't have to be overly elaborate. And in fact, my attention span doesn't really encourage overly elaborate answers, right? Because I tend to zone out. So keep it simple. So what's the y-intercept?
1/2.
1/2. Y-intercept is 1/2. And is it growth or decay?
Growth.
Growth because
B is greater than 1.
b is greater than 1. Nice and simple. All right. Now for number 2, write an exponential equation in the form of a times b to the x based on the given table. All right. So here we don't have a y-intercept, but we can figure out based off of the progression here what that y-intercept would be if you had another little cell there. So what I'm going to do is I'm going to tuck in a little 0 here. What would the y value be corresponding to that 0? 1024. All right, and we know that because if we're going from right to left, we're multiplying by 4 every step of the way. But that's not really the way you want to think about it, because when you're dealing with an exponential function, I mean, while that could be the best way to get you to the 1024, we do need to know what's happening to y as we're increasing x. All right, so what would my b value be?
4.
1/4. All right, because we need to go that way, it would be times 1/4. All right, so this is always left to right. All right, so by going right to left, we were able to easily figure out what the a value would be. But in order to figure out the b value, we need to go from left to right. All right, so we know that the a value, which is the y-intercept, has to be 1024. And so therefore we would say y is equal to 1024 times 1/4 to the x power. All right, now I'm going to kind of save this big reveal for the next unit when we talk about linear regression and things like that, but there is a function in your graphing calculator that'll take a list of data and write this equation for you, all right, so that you don't have to do this work. That being said, it's not too crazy of a procedure, so honestly, I think you probably figure out this answer before you even finish typing in the data to your calculator. So it'll be one of those things where I'll show you how to do it, and then you decide whether it's something that you want to do. All right, but there is a calculator shortcut that could help us get that solution. All right, but we have to learn something else before we can figure that out. All right, so exponential growth, as we know, we're going to focus on, we'll focus on that for now, but exponential growth is increasing as you go from left to right. 2 equipment rental companies have different penalty policies for returning a piece of equipment late. On day 1, the penalty is $5. On day 2, the penalty is $10. On day 3, the penalty is $15. Day 4, the penalty is $20, and so on, increasing by $5 each day the equipment is late. Company 2, on each day the penalty is 1 cent. On day 1, the penalty is 1 cent. On day 2, the penalty is 2 cents. Day 3 is 4 cents. So this is the classic. If you remember, maybe it was, I don't even know if they do this in middle school anymore, but I remember it was like in 6th grade, the challenge question was, which would you rather have, $1 million right now, or you start off with 1 penny on the first day of the month, and you double it for every day of the month, you get all that money at the end of the month. Which would you rather have, the $1 million flat, or start with that penny on the first day and double it for every day of the month, with you getting the total amount at the end of that month?
$1 million. You invest that.
$1 million, then invest it, right? So, well, if you figure it out, then maybe you decide, I think I'd rather have the the other situation. All right, this is that scenario playing out. All right, so we're actually going to see what's going to go on here. We're going to create a table. The one thing I would say that makes company one's penalty a little bit more favorable is that you know what the penalty is going to be. Like, you don't have to do math to figure that out. You know each day is going to cost you an extra $5. All right. If I were to ask you right now what your penalty for company two is going to be on the 14th day, you're probably going to need to whip out a calculator for that. All right. So on day 0, well, you're not late, right? So there's no penalty. On day 1, penalty is $5, right? Day 2, $10, 15. Day 4, 20, increasing by 5 every step of the way. Oh, sorry, dude. I thought you were... All right, so what we have here is a constant rate of change. All right, company one is a constant rate of change. All right, what that means is that your difference in consecutive values is always going to be 5. All right, to get from day 0 to day 1, or from day 8 to day 9, it's still going to be $5, no matter how you slice it. All right. So what that tells me, now constant rate of change, that sounds fancy, but what it really tells me is that it's a linear function. A linear function, the equation of a line, all right? So based off this data table, I have everything I need in order to write the equation of this line, because the equation of a line is in the form of y equals mx plus b, right? Or that's one form of it anyway. This is the best form of the equation of a line if you can already identify what the y-intercept is. All right? Because, you know, we have the two different forms. We have the standard form. I made a chart yesterday. I had a little time on my hands. So the different types of functions, parent functions, and also the equations that go along with them. The very first one on the list, the first one that we learned about this year, was the equation of a line. That standard form involves a point, so any coordinate on that line, and the slope. All right, so that works in any case. But this one, y equals mx plus b, is really nice if you already know the y-intercept. All right, what's the y-intercept for this data set? It's 0. All right, so we're good to go. My function, well, they said write a function, so we should use f of x. Would be, so mx, what's my slope? 5. So 5x plus 0, so I'm just going to write 5x. All right, and this tells me what my penalty is going to be depending on the number of days that I'm dealing with. So if I'm at the 60th day, I could figure out, based off of this function, what my penalty is going to be. That's not bad. Right? I mean, the numbers can get pretty large. I mean, if you wait like 10 years, that's a significant penalty. But, you know, maybe based off inflation, it's not that bad. So company 2, starting off with a single solitary penny. 0.01. Oh wait, 0. So day 0, we got to start with that. On day 1, it's still the single solitary penny. On day 2, 2 pennies, right?
Yep.
Then 4 pennies. 8, 16, 32, 64. After day 8, we finally cracked the dollar barrier. I mean, this isn't bad. I mean, if I borrowed a piece of equipment from company 2, I'm keeping it for an extra week. Because I'm only gonna pay on the 7th day, only a penalty of 64 cents. I might even keep it longer than that, we'll see. $2.56, $5.12. Okay, so now we're starting to outpace company 1. All right, well, at least in terms of how much we're gonna pay on a daily basis. All right, because the rate of change for company 1 was $5 per day. So now I'm gonna start outpacing that because now I'm up to 1024. 2048. 4096. 8192. And then 163.84. All right, so on the 14th day, we've already outpaced. I mean, we've already accumulated more penalty than company 1. All right, so at that point, it's more advantageous to go with company 1. All right, so if you planned on never returning this equipment or keeping it for years and say, well, I'll just pay the penalty, in the long run, you want to keep company 1's equipment. But you don't want to keep company 2 because after that, it's going to get crazy. Now, you could take it the rest of a single month and you could see that you're already going to be in the millions, at least in the millions. All right. So what we're doing is we're getting from one number to the next by doubling, right? So times 2, excluding the start value, because again, there's no penalty if it's not late. All right. Each step of the way, we're doubling. So what we need to do is come up with a function for this. Now the issue is, now this is a significant issue. What happens when you double 0?
Nothing.
You get 0. All right, so we can't include this value here. Even though day 0 should have a penalty of 0, it's not part of this function. All right, it can't be because it wouldn't satisfy the requirements of the function. But what I do need is a y-intercept that would fit this exponential function. So again, exponential, because we're multiplying by a constant value. All right, so constant multiplier. So it's exponential. And therefore it's going to be in the form of y equals a times b to the x. All right. So we know, I'll call it g of x. We know it's going to be something times 2 to the x power. I just need that something, and it's not 0, because the whole thing is 0 out.
0.001.
0.001.
1.
Well, that's not half of 0.01.
0.005.
0.005.
Correct.
All right, and that goes back to the do now problem, where if you want to dial it back to the 0, just do the reverse of the operation. So if I'm going from, this would be equivalent to left to right. I know it's top to bottom, but left to right, we're multiplying by 2. If you want to go the other way, you're cutting everything in half. So if I wanted to go back one step along this function, I would chop this number in half and get 0.005.
So wait, why doesn't 0 work again?
Because if you were to follow this idea of multiplying by 2 every step of the way, if your starting value is 0,
Oh yeah.
it'd still be 0. It'd always be 0.
Okay. So up through 14.
Exponential.